Hello guys, and then welcome to another video. From our previous video we got to study some portions or subtopics under complex numbers. Okay, we took time to study the addition, subtraction, finding arguments, modulus, and then polar representation of complex numbers. Okay, so in this subtopic we'll be dealing with finding the trigonometric functions of complex numbers, but using the Moivre's theory. Okay, so we know that the Moivre's theory could be represented as this. Okay, so whenever you are given an example which is especially the trigonometric function, it will be given in a form like this. Okay, right, so that you just expand and then find the powers. Okay, just like this example. Okay, in this example we'll be expressing sine 3 theta, okay, and cos 3 theta in terms of the powers of cos theta and then sine theta. Okay, so in this form, so all you have to do just from here is to just rewrite the exact expression. Okay, we are representing cos sine 3 theta, okay, and then cos 3 theta in the form of this. Okay, meaning that all the answer we'll be getting for cos theta has to correspond to the real portion of the complex number. Okay, just like here. Okay, hope you remember something like x, okay, plus maybe yi. Okay, yeah, so from our previous video we got to calculate complex numbers in the form of polar, okay, representations and then rectangular representations. In case you haven't watched that video, you can just go back or check the link in the description, or just go to our channel and then you find the video right there. Okay, so let's get right into this video. Before I proceed, in case you are new here, kindly subscribe. Okay, kindly subscribe to help us grow this channel. Okay, subscribe and then hit on the bell icon and then like the video, share the video, and then in case you have any other questions, kindly let us know in the comment section below. So just like this, we'll be representing, okay, in this form. So we'll be representing this in that form. Okay, we have cos, okay, theta, okay, plus, so since this is in the form of sine theta, sine 3 theta and cos 3 theta, this is how we will be representing our expression. Okay, so sine theta, okay, just like this, and then over here, right, just like this form. Okay, now once you get to this point, all you have to do is just expand it. Okay, so one trick you have to know is the binomial expansion. Okay, because this is in the form of an expression like let's say we have x, okay, plus iy, okay, something like this. Okay, so that you get to understand what I'm trying to do right here. So let's say you are doing the binomial expansion. This is what you have to know. Okay, there's a certain trick you use. So this is how it goes. So you just first write 1, okay, as the first, and then you expand the 1. Okay, now we have 1 here, 1 over here. So all you have to know is that all the borders have to be 1. Okay, so all the borders have to be 1. Okay, but the middle values have to be added. Okay, so this is what I mean. So the borders have to be 1. Okay, just like here, started with 1, the borders have to be 1, but when you get to the middle, you notice that you have to add 1 plus 1 to get what? 2. Okay, so the borders have to be 1, but when you get to the middle, just add the values in the middle. Okay, so you have the border over here, another border over here, so you add this to this, and then you get what? 3, right? And then you add this to this, then you get what? 3. So from here you could see that this expansion is raised to the power 3. Okay, so it means that this is a correct expansion. So we'll be first dealing with the same example in terms of x and y, and then we will just substitute the values, okay, into cos theta and then sine theta, so that you get to understand what we are trying to do. Okay, so let's start from here. So this is what you have to do. this is what we will be using. Okay, this is the expansion we will be using. Okay, so take note of this. We are expanding this, but we will be not doing the normal expansion, that's x plus iy, and then multiply them together. After that, you get, after getting the expansion, you multiply the same expansion with another x plus iy. Okay, we will be not doing that. We will just use this binomial expansion. Okay, and then we'll be able to arrive at the exact expansion. Okay, so this is what you do. First, keep this one. Okay, 1, mind you, this is what we are expanding. Okay, this is what we are expanding. So 1, and then we have x. Okay, so we have a certain x. Okay, you first raise it to the power 3. Okay, right, and then plus this 3. Okay, and then you multiply this one with this one. Okay, so you have x multiplied by I, okay, y. Okay, but note, once the real portions keep on increasing, okay, the powers also keep on decreasing. Okay, so from here you could notice that the power of the x was 3 over here, but here the power of the x is what? 2. Okay, it will keep on decreasing. Okay, and then we have plus, keep at 3. Okay, now since our real portion is decreasing, so it started decreasing from here, so we have power of 3, power of 2, so here we have just x. Okay, and then this, the imaginary portions will start increasing. Okay, so from the real portion we have x exponent 3, x exponent 2, right? But from here we could see that this iy exponent 0, no. Okay, or let's say iy exponent 1. Okay, we don't write exponent 1. Okay, so we have iy exponent 1, so from here it will increase. Okay, so we have iy exponent what? 2. So guess us right. Okay, then we have plus 1. Okay, so we have 1, then open your brackets. We have, so from here we have x exponent 0. Okay, so x exponent 0 is what? We don't write it, it's just 1. Okay, and then that 1 will multiply this. Okay, so we have I y, okay, exponent 3. So when you expand this, you notice that you get s cubed, okay, plus this. Okay, so we get 3 s squared iy. Okay, and then from this we know that this squared will be I squared multiplied by y squared. Okay, take note, it's small, it's the power of the I, okay, and then the y. It's not just the y, for both, it's for both the I and the y. So we have minus 3x, okay, y squared, right, because I squared is minus 1. Okay, and then from here we have this also I cubed y cubed, so we have minus I, okay, minus I, and then y cubed. Okay, so once you understand this, you can just proceed. Okay, this is what you have to do. So all you have to do is just represent our x. Okay, so from here this is our x, and this is our iy. Okay, okay, so we have the cos theta is our x. Okay, and then the I sin theta is our iy, right? Yes, the cos is our x, this is our x, okay, and then this is our iy. Okay, just from here, right? Okay, so let's proceed. So we have, so this will be what? Cos, right? Cos exponent 3 theta, okay, plus 3x. Okay, so you know that that is cos, okay, squared theta. Okay, and then we have what? Y is what? Sine. Okay, we have sine theta. Okay, and then we move on to minus 3 again x is what? Cos theta, right? And then we have our sine. There's only y, so we have sine, only sine. Okay, so sine squared theta. Okay, and then we have minus I. Okay, so we have I, right? And then y cubed, so we have sine, okay, theta. There you have it. Okay, so our x's are represented by or are replaced with cos theta, right? And then our y's are represented or replaced with sine theta, and then our i's will just remain the same. Now this is how you do your expansion and expression. Okay, so now we have to express sine 3 theta and cos 3 theta in this form. Okay, in this form. So all you have to do is just write your cos 3 theta. Okay, note that the cos 3 theta, okay, is the same as the real portion. Okay, the real portion of the expression. That's where we don't have i's. Okay, so from here you could notice that there's no I in this expression. Okay, so we have cos exponent 3 theta, and then we have I over here, so this will be the imaginary portion. Okay, and then from here we don't have any I, so we have minus, so we have minus 3 cos theta, okay, sine squared theta. Okay, now we are done with the real portion. Now let's look at the imaginary portion. So we have sine, okay, 3 theta. Okay, so we have sine 3 theta equals, from here we could notice that we have I in this expression, so we just represent it by that. So we have 3 cos what squared theta. So I will be here, but you can decide to just omit it. Okay, because you know that that portion is just the imaginary. Okay, so we have, and then we have sine theta. All right, and then we have I over here, so we have minus sine, okay, cube theta. Right, now one thing you have to know is that there are some expressions we can substitute some of these equations with. Okay, so from here we could notice that we have a mixture of 3 cos theta and then sine squared theta. Meanwhile, we just want the real portions of the expression to be in only cos. Okay, and then for the sine theta, we also need the expressions within this example to be in what's only sine. Okay, so there is something we call trig functions. Okay, so you have to know some of these trig functions, okay, these trigonometric functions, so that you can use them in substitutions and all that. Okay, so we have one which is since we know that cos squared theta, okay, plus sine squared theta, okay, will give us 1. We can just substitute, we can just make one of these the subject and then substitute them into this, okay, into, let's say, equation 1 and then equation 2. All right, yes, so let's make cos squared theta the subject in this expression. So we have cos squared theta will give us 1 minus sine squared theta. Okay, and then let's say this expression 3, right? And then let's make sine squared theta the subject. So we have sine squared theta, okay, will give us 1 minus cos squared theta. So this will be our example 4. Okay, now all we have to do is either substitute equation 3 into 1 or equation 4 into 2. Okay, all you are trying to do is just keep the cos theta constant. So we don't need any signs in the cos expression, okay, and then we don't need any cos in the sine expression. So from expression 1 or equation 1, we can just substitute sine 2 theta with 1 minus cos squared theta, so that we just remove the sine expressions in the real portions of the expression. Okay, so substituting equation 4 into 1, okay, we will have, let me use another color. Okay, you can comment in the section below the color you prefer I use. Okay, so we have cos cube theta. Okay, so from here we have cos cube theta minus 3 cos theta. Okay, and then we have this expression, right? This expression. So we have 1 minus 3 cos squared theta. Okay, and then when we expand this, we will get cos cube theta. Okay, minus this by 1 will give us 3 cos theta. Okay, and then this by this will give us plus 3 cos cube theta. Okay, so this by this will give us this. Okay, so from further simplification, we have our final answer to be, this is cos cube theta, and then this is cos cube theta. So we can write this as, this is cos cube theta 3 plus 3 cos cube theta. So we have 4 cos cube theta, okay, minus 3 cos theta. So this represents the real portion of the trig function of the complex number using the Moivre's expression. Okay, now let's look at the imaginary portion. Okay, the imaginary portion of the complex number. Okay, so we have this expression, right, representing this. Okay, so all you are trying to do is just substitute the cos squared theta with a certain expression. That's the equation 3. Okay, so this is what we'll be doing, substituting this into the cos squared theta. Okay, so we have 3, okay, cos squared theta, so that will give us this. So cos squared theta is 1 minus sine squared theta. Okay, cos squared theta is this 1 minus sine squared theta. So we have this 1 minus sine squared theta. Okay, and then we have what? Sine theta. Okay, sine theta. Okay, so we have sine theta. Okay, and then we have minus sine cube theta. So we have minus sine cube theta. Okay, now let's expand this. So we have this. So we have, let's first multiply this throughout. Okay, so we have 3, and then minus this by this will give us 3 sine squared theta. Okay, like that. Yes, and then minus sine cube theta. Now let's expand this further. Okay, so we have this multiplying this, okay, will give us 3 sine theta, right? Then minus this multiplying this will give us 3 sine 2 multiplying 1. Okay, so we have that's indices, so when they are the exponents we add them. Okay, so we have sine cube theta, okay, and then minus sine cube theta. Okay, now let's simplify it further. We have sine cube theta. Okay, once we have sine cube theta and then sine cube theta, you will just further simplify it. Okay, so we have 3 sine theta, okay, minus 4 sine cube theta. Okay, so from here you will notice that this also represents a imaginary portion of the complex number. Okay, yes, so we have this. So our final answer will be for cos theta we have, this is the final answer for cos theta, and then this is our final answer for sine theta. Okay, so let's just simplify this further. So we have this sine 3 theta, okay, will give us 3 sine theta minus 4 sine cube theta, and then we have cos 3 theta, okay, will also give us the expression up there. So we have 4 cos 3 theta, okay, minus 3 cos theta. Okay, so now we've simplified an entire expression. Okay, so we've been able to express sine 3 theta and then cos 3 theta in terms of powers of cos theta and sine theta. Okay, so we've been able to express sine 3 theta in terms of the powers of sine theta and what cos theta. Okay, so these are our final answers. So in the next video I will show you how to do this, okay, in less than 60 seconds. Okay, there's no need for you to do the binomial expansion and then other expansion, okay, or trying to memorize trigonometric functions. Okay, so in the next video I will show you how to do the exact thing but with an easier approach. Okay, so kindly subscribe to the channel in case you are new to this platform, okay, and then share the video, like, and let me know whether you have any further questions for me in the comment section below. See you in the next video. Bye bye.